Hello again everyone, and our topic for today is on illustrating polynomial functions. Our topic involves identifying the following. Number 1, polynomial from not a polynomial. 2, standard form and factored form. Degree of a polynomial function. Leading coefficient, constant term, and leading term. So what is a polynomial function? So a polynomial function is a function of the form p of x is equal to a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 x n minus 2 plus a sub 1x plus a sub 0, where a sub n is not equal to 0, where n is a non-negative integer, a sub 0, a sub 1, until a sub n are real numbers called coefficients. A sub n x raised to n is the leading term, and a sub n is the leading coefficient, and a sub 0 is the constant term. So a polynomial function can also be written as the following. So as you can see on the screen. So we have here examples. So we have p of x is equal to 4x cubed plus 5x squared plus 8x minus 10 is also written as f of x is equal to 4x cubed plus 5x squared plus 8x minus 10, or y is equal to 4x cubed plus 5x squared plus 8x minus 10. So how do we identify a polynomial from not a polynomial? So here is an example of a polynomial function. P of x is equal to 4x cubed plus 5x squared plus 8x minus 10. So it is written in decreasing power of x, and the polynomial function is in standard form. So a polynomial, to be identified as a polynomial, the variable should not be in the denominator. Number 2, inside the radical symbol, a negative exponent, or a fractional exponent. So a polynomial function can also be written as standard form and factored form. So here are the examples of polynomial functions written in standard form and factored form. So let us identify a polynomial function's leading term, leading coefficient, degree, and constant term. So let us identify what is a leading term. So a leading term is the term with the highest exponent. The leading coefficient is the numerical coefficient of the leading term. The degree of a polynomial function is the highest exponent, and the constant term is the numerical value having no variable. Let's have an example. So let us identify the leading term, the leading coefficient, degree, and constant term of p of x is equal to 4x cubed plus 5x squared plus 8x minus 10. So the leading term is 4x cubed, the leading coefficient is 4, the degree is 3, and the constant term is negative 10. So let's have another example. So let us identify the standard form of a given polynomial function, the degree, the leading coefficient, the constant term, and the leading term. So let us solve for example number 1. So we write it in a standard form. So f of x is equal to 2 minus 11x plus 2x squared. So if we write this in standard form, we have f of x is equal to 2x squared minus 11x plus 2. So the degree of this polynomial function is the highest exponent, which is equal to 2. The leading coefficient is also found in the leading term, which is 2. The constant term is also 2. And the leading term is 2x squared. So let's have another example. We have f of x is equal to 2/3 x cubed plus 5/3 plus 15x. So if we write it on standard form, we have f of x is equal to 2/3 x cubed plus 15x plus 5/3. So the degree of this is equal to 3, which is the highest exponent. So the leading coefficient is equal to 2/3. The leading or the constant term is equal to 5/3. And the leading term is equal to 2/3 x cubed. So let's have another example number 3. What if it is written in factored form? So 3, 4, and 5. Written in factored form. So the first one is we need to solve for the standard form of these polynomial functions. So this is how we solve the standard form of example number 3. So y is equal to x times the quantity x squared minus 5. So we multiply x squared minus 5 times x. So in finding the standard form of this polynomial, we need to multiply x squared times x. So it becomes x cubed minus 5 negative 5 times x, or that is negative 5x. So the standard form of y is equal to x times the quantity x squared minus 5 is x cubed minus 5x. So we will write it on our table. So the standard form for y is equal to x times the quantity x squared minus 5 is equal to y is equal to x cubed minus 5x. The degree is equal to 3, which is the highest exponent. The leading coefficient is 1. So the constant term is equal to 0 because it has no constant term. And the leading term is equal to x cubed, the term with the highest exponent. Next number, we have example number 4. Y is equal to the quantity negative x times the quantity x plus 3 times the quantity x minus 3. So the same process as we did in example number 3. So we multiply the 3 factored form of that polynomial function. So y is equal to negative x times the quantity x plus 3 times the quantity x minus 3. So we are able to find the standard form of this by multiplying the 3 factors. So first, we multiply x plus 3 and x minus 3. So first, we multiply x plus 3 times x minus 3. So x times x, it gives us the answer of x squared. Next, x times 3, it gives us the answer of positive 3x. Then negative 3 times x, it gives us the answer of negative 3x. And then positive 3 times negative 3, that is negative 9. So we add the 2. So x squared, we bring down. And then we cancel positive 3x and negative 3x because the answer is 0. And then we bring down negative 9. So this is not yet the final answer. So we multiply again negative x. So x squared times negative x, it gives us negative x cubed. And then negative 9 times negative x, it gives us positive 9x. So the standard form of y is equal to negative x times the quantity x plus 3 times the quantity x minus 3 is equal to y is equal to negative x cubed plus 9x. So the degree of this is equal to 3, which is the highest exponent. The leading coefficient is negative 1 because the numerical value of x x cubed is equal to negative 1 and the constant term is 0 and the leading term is equal to negative x cubed. So let's have example number 5. So y is equal to the quantity x plus 4 times the quantity x plus 1 times the quantity x minus 1. So we solve for the standard form of this polynomial function. So first, we write y is equal to the quantity x plus 4 times the quantity x plus 1 times the quantity x minus 1. And then first, we multiply x plus 4 times x plus 1. So first, we multiply x plus 4 times x plus 1. So, in multiplying these two factors, we first multiply x times x, so it gives us x squared. And then, 4 times x, it gives us 4x. Another, 1 times x, it gives us x or 1x. And then, 4 times 1, it gives us 4. So, we add the two, x squared, we bring down. And then, we add 4x plus 1x, it gives us 5x. And then, plus 4. Finally, we multiply to the answer the x minus 1. So, x minus 1 multiplied to x squared plus 5x plus 4. So, first, we multiply x squared times x cubed. So, 5x times x, it gives us the answer of 5x squared. And then, 4 times x, it gives us 4x. Next, negative 1 times x squared is negative x squared. So, we aligned it in the same exponent or negative 1x squared. Negative 1 times 5x, it gives us negative 5x. And then negative 1 times positive 4, it gives us negative 4. So, we add again the 2. So, we bring down x cubed. So, we bring down x cubed. And then we add 5x squared minus x squared. It gives us 4x squared. And then we also add 4x and negative 5x. The answer is negative 1x or simply x. And then we bring down negative 4. So, the final answer is x cubed plus 4x squared minus x minus 4. So, we will write this on our table. So, the standard form of y is equal to x plus 4 times the quantity x plus 1 times the quantity x minus 1 is equal to x cubed plus 4x squared minus x minus 4. So, the degree of this polynomial function is equal to 3, which is the highest exponent. So, the leading coefficient is equal to 1. The constant term is negative 4 and the leading term is equal to x cubed. Next example, we have number 6. This is just like example number 1 and 2. We can easily identify the standard form of this polynomial function because it is already arranged in decreasing powers of x. So, we have 2x cubed plus 5x squared plus 7x minus 5. That is the standard form. So, the degree of this function is 3. The leading coefficient is equal to 2. The constant term is equal to negative 5. And the leading term is equal to 2x cubed. Last example, we have example number 7. So, f of x is equal to x cubed plus x plus 18. So, the same as in example number 6, it is already arranged in the decreasing power of x. So, x cubed plus x plus 18 is the standard form. The degree of this is equal to 3. The leading coefficient is equal to 1. The constant term is equal to 18. And the leading term is equal to x cubed. So that's all for today's lesson, and don't forget to like, share, and subscribe to our YouTube channel for more videos.